Okay, moving on to number 4 in 15.2. It says find the inverse of the one-to-one function. Now might want to research a little bit on YouTube about inverse functions. It's kind of an interesting idea. Is we're gonna interchange the x and the y value of a function, and then what's gonna happen with that function is it's gonna reflect about the line y equals x. Okay. So you might want to just do a little more research on that. But to find the inverse of a one-to-one function, if we're given a one-to-one function, they're all going to follow the same rhythm. Okay. The first thing you want to do is replace the function's name with y. Okay. So we could do that with all of these problems if we wanted. We could say, okay, replace the function name with y. Okay. Replace the function name with y. Okay, so that's the first step. Okay, then the next step is to just flip-flop or interchange the x and the y. So what I'm going to do is, since I see x here, okay, I'm going to write x over there, and so I get x equals 8y plus 4. I can do that on this one too. It's kind of strange. I'm working 3 different problems at once, but the steps are the same, so I just kind of want to emphasize that. And then on this one, I'll interchange the x and the y. So, okay. So that first step, the first 2 steps, okay, the same. And I've written them out on your note packet so you can write down the steps. So now I'm going to work on this one. I'm going to solve for y. Okay, solve for y. Okay, oops, solve for y. Okay, so to solve this for y, I'll subtract 4, and get x minus 4 on this side equals 8y, divide by 8. So our normal solving steps here. Okay. And then what I get here is I get x minus 4 over 8 equals y. Now, in the Hawk system, you won't have to do this last step, but this step is to replace y with this thing called inverse notation. And you write the inverse notation by writing this little -1 power up here. And so that's the inverse notation. And we get x minus 4 over 8. Okay, so let's look at those steps here. So I'm going to solve for y. I'm going to subtract 2. All right, easy enough. Get x minus 2 on the left side equals 3/2 y. Some students will divide by 3/2 here. I'm going to multiply by 2/3, multiply by the reciprocal, multiply this side by the reciprocal. And what I get is 2/3 x and minus 4/3 equals y. And then I want to use that function notation, the inverse notation. And so I'm going to say g, since my original function, g of -1, or g, the inverse of g of x equals 2/3 x minus 4/3. Okay. And then on this last one here, I'm going to add 10. So I'll do that in red so you see the solving steps here. Add 10, and get x plus 10 equals 12 over y. Now this we've seen in a previous module, and you got to be a little careful with it. It's a little trickier solving. You could put this over 1 and then cross multiply, so we'd have y, there's from the cross multiplying, equals 12. And then I'll divide by x plus 10, divide by x plus 10. And what I get is taking this to knowing that I'm going to write the inverse notation, I'll write f of minus f to the minus 1 of 12 over x plus 10. Okay, so the inverse of f of x is equal to this. So this is the original function. This is the inverse. And what you might want to do is just type this into Desmos and then type this into Desmos. And what you'll see is that this original function is going to flip around the line y equals x. Okay, so you'll see a kind of a symmetrical looking picture. So remember, if we have a one-to-one function, we can find its inverse by doing these steps. Okay, and what this is going to do is, in a little bit, it's going to lead us into a new thing called logarithms.